Prepare the tools: electrofusion machine, hammer, grinder, multimeter, tape measure, white marker, and towel. Use a grinder to polish the pipe surface to remove oxide skin. Polish a slightly longer area than the insertion depth. Grind a bevel at the pipe end. Use a tape measure to measure the pipe insertion depth and mark on the pipe. Wipe the polished pipe section and the inner wall of the fitting clean with a towel. Before installing the electrofusion fitting, use a multimeter to test resistance and check connection between copper pins and heating wire. Insert the pipe into the fitting. Do not hit the copper terminals of the fitting. Place a wood board for cushioning. Tap the board to push the pipe until it reaches the mark. Keep the pipe centered, do not tilt it. Plug the copper connector into the copper pins of the fitting. Enter the parameter values on the fitting into the fusion welder accurately, and turn off temperature compensation. Press confirm button to start welding. Maintain a safe distance. Do not look directly into the safety aperture. Observe whether the voltage of the welding machine is stable. If it is below 220 volts or fluctuates, the welding quality will be affected. Once welding is complete and the weld has cooled, after confirming that the overall welding is complete, observe whether the pin rises. 1. Pressure testing may only be performed after welding is complete and the product has cooled. 2. During the cooling process of the piping network, avoid the application of external forces such as knocking, pressing, pulling, or stepping on the pipes and do not move or relocate them. 1. Failure to remove the oxide layer will severely compromise welding quality, leading to issues such as cold joints or a failure to bond. Tools like scrapers or glass are ineffective at properly removing the oxide layer. 2. Failure to fully insert the pipe into the fitting can cause welding short circuits, as well as smoking or fire. For fitting size 315 mm and above, the open ends of the pipes should be sealed with plastic film prior to welding. 3. During seasons with high or low temperatures, the total duration specified in the final stage of the parameters should be adjusted by up to 10. In conditions involving significant temperature differences where thermal expansion and contraction are pronounced, site personnel must check for any displacement of the reference marks prior to welding and make timely corrections if such displacement has occurred. 4. Use welding machines and cables that meet the required power specifications. The cables should be located no more than 50 meters away from the generator's power distribution equipment. 5. Proceed with the overall backfilling only after confirming that the pressure test results are satisfactory. 6. For pipes with a wall thickness of 10 mm or less, the welding time should be reduced by 10-15 as appropriate. 7. For pipe fittings with a diameter of 315 mm or larger, tensioning tools such as lever hoists may be used to prevent excessive pipe retraction and the emission of slurry or smoke during the welding process. 8. During pipe installation, the bottom of the trench must be leveled. For long pipeline networks or areas with loose soil, expansion joints or flexible connectors should be appropriately installed to accommodate tensile forces resulting from factors such as pipeline or foundation settlement during operation. 1. Connection. Connect the pressure testing equipment to the piping system to be tested. Install the necessary valves and pressure gauges within the system. Install air release valves at the system's discharge end, highest point, and terminal points, and install drain valves at the lowest point. Secure the positions of T's and elbows using wooden stakes or steel bars, and perform partial backfilling. Backfilling prevents the piping network from shifting during pressure testing while leaving the pipe fittings exposed for future maintenance. Without backfilling, improperly welded pipes or fittings could separate under high pressure, and a dislodged fitting could injure construction personnel. 2. Water filling and air venting. Open the air vent valve and close the drain valve located at the lowest point of the system. Fill the piping system with water and close the air vent valve once a steady stream of water flows from it. 3. Inspection. After the piping system has been filled with water, do not rush to increase the pressure. Instead, first inspect the system for any signs of seepage or leakage. During inspections, personnel should observe from a distance to prevent damage caused by the pipe network shifting or dislodging. 4. Pressure increase. 1. Only hydrostatic testing methods may be used for the pressure test. 2. After the pressure is raised to the specified test pressure, stop pressurizing. If the pressure drop does not exceed 0.05 megapascal after maintaining the pressure for approximately 1 hour, the pipeline pressure test is deemed to have passed. 5. Post-pressure test procedures. Upon completion of the pressure test, if the ambient temperature is below 5 C and the pipeline is not to be put into immediate use, any water remaining in the piping system must be drained promptly. 1. Before the pressure test, when filling the piping system with water, fully open the air release valves to purge all air from the pipeline. 2. During pressure testing, the ambient temperature shall not be lower than 5 C. If the ambient temperature is below 5 C, anti-freezing measures must be taken, that is, slowly fill the pipeline with water after covering it, and wait 24 hours for the water temperature, ground surface temperature, and pipe buddy temperature to equalize before conducting the pressure test. 3. During the water filling process, once a steady stream of water appears at the air release valve, close the valves sequentially starting from the discharge end and perform air venting multiple times. Air venting must be carried out at least 3 times. First, after the system is filled with water. Second, when the water pressure rises to 0.2-0.3 MPa. And third, when the water pressure rises to 0.5-0.6 MPa. 4. The test pressure must not exceed the ultimate pressure rating of the pipes and fittings. Repeated high-pressure testing can also damage the piping network. 5. After successful pressurization, a certain level of residual pressure should be maintained to prevent damage caused by rapid contraction of the piping network. 6. For test pressures of 10 kg per square centimeter or less, a 16 kg per square centimeter pressure gauge should be used. For pressures above 10 kg per square centimeter, a 25 kg per square centimeter gauge is required. 7. During hot summer weather, it is recommended to conduct pressure testing in the early morning or evening to avoid damaging the piping network due to high temperatures. 1. Pipe fittings with a size of 200 mm or smaller are welded using a 220 volts power supply, while those with a size of 250 mm or larger are welded using a 380 volts power supply. 2. For pipe fittings up to 160 mm, a 2.5 kilowatts welding machine may be used. For 200315 mm fittings, a 6.5 kilowatts welding machine. For 315500 mm fittings, a 12 kilowatts welding machine. And for 5601000 mm fittings, a 15 kilowatts welding machine.
If pipes, oh my god, cheap and good, just buy it now.